Okay, so we're talking about translations. And we're taking functions when we are translating them, like moving them. And so I want to start by, let's see if I can get a good graph up. There we go. Okay. If I take a transformation of the parent function of a parabola, the parabola would kind of look like this to start with. That's just a rough sketch of one. If I take that and I decide to move it like to the right and then down a little bit, you learned about how to do that yesterday. Now we're going to get into much heavier duty stuff. We'll be also like shrinking them down or even stretching them out. We will also be flipping them upside down, all kinds of different transformations. And so I thought I would show you a clip. I'm going to pause for a moment while I show the classic clip from YouTube. So here are two words that you need to understand. Transformation, that's a change in the size or position. See what I'm going to do here? Change in the size or the position. Oop, look at that. I transformed it. Okay, anyway. Transforming is any kind of a change in the size or the position. A translation is specifically sliding it like this, not changing its size, but just sliding it left or right. That's a translation. It's very easy to like get those confused. Transformation versus translation. Transformation is any change, any type of a change, and translation is only a slide. Like left, right, up, down, just a sliding it. It cannot change size. Okay, so here's a function, f of x equals x. That's a function. And that function is this black line right here. That one. Okay, and if I do this to it, I move it up 6, and that becomes the red one. And this, if you just move it straight exact up, that's how it becomes this other function. It just slides up 6. And I hope you figured out yesterday the general idea for these functions. I would want you to know a few of these functions by heart. Like, if I say y equals x squared, you should automatically go, oh yeah, that's this one. Right? All right. I also want you to know y equals square root of x, which is that one. And I also want you to know y equals absolute value of x, which is that one, the V shape. So I'm going to call them the V shape, the U shape. Those are pretty obvious. And this one I'm going to call the ramp. I don't have a better way of saying it. It just keeps going up and up and up. It's like a ramp or a hillside or I don't know. Any other thoughts? Square root. Yes, it's the square root graph, but okay, anyway, I think maybe we were saying it kind of looks like the square root itself. Like this is kind of like it, but it doesn't really look like that because that's totally flat on top, and this one keeps rising. And anyway, okay, so those three are really, really crucial for today. Then the other part is this part I kind of skipped over right here. You have to understand the general form. If you have a function, we just throw in the letter f. It could be any of those functions. You just throw in an f. You don't know which one it is unless they tell you. Okay? But it's a function. And then whatever you do in here, like subtracting h, or subtracting 2, or subtracting 10, or adding 17, all that stuff on the inside is left, right. This is worthy of you writing down somewhere. Inside is left, right. And the stuff over here on the outside is up / down. Anything that's on the outside of the parentheses or outside of the function is up, down. So I should be able to rapid fire give you some, and you should be able to say, oh yeah, that's a U shape and it's been moved up 3 and down, no, up 3 and right 2 or whatever. Okay, so inside's left, right, outside's up, down. One more quick thought. The stuff on the inside does the opposite of what you would expect. For example, if I say y equals x squared, you know that one is like this. And if I go like this, y equals x minus 3 squared, that, to me anyway, seems like it should be going to the left 3. Because the negative numbers, xy's, are over here. That's where the negatives are. So it seems like it should be moving 3 to the left, but it's not. It's always the opposite of what you would intuitively think. All right. So this stuff in here is the opposite of what you'd think. I'll show you another one that we're going to do later this year. So when you have like 2x squared, that's going to take your parabola and make it not twice as wide, which is what you would think. It makes it half as wide. That actually shrinks your parabola. Even though it doubles the inside, it does the opposite of what you'd expect. It's not twice as wide, it's half as wide. Okay. And also, for instance, if I were to divide by 4, you'd think it would get 4 times smaller. Nope. Get 4 times bigger. That was the opposite of what you think. On the outside, however, it is what you'd expect. Plus 8, if your choice is up or down, which one seems logical to you? Okay, you're not paying attention. Shut your iPads. I'll get you back in them in a second. I said, if I were to do something on the outside like plus 8, which one seems logical to you? Should that be up 8 or down 8? Up 8. And it is up 8. It's exactly what you'd expect. The stuff on the outside is what you would expect. It's not counterintuitive. Stuff on the inside is the opposite of what you'd expect. So rapid fire, just tell me verbally, what would this one be? iPads shut, please. X minus 2 squared plus 7. What shape is it? Parabola. And it's been moved which way, right or left? Right how many? All right, and it's been moved up or down? Up how many? All right, good. This one is what shape? That's a V shape, and it's been moved which way? Left 3, and then down 8. All right, good. You're getting the idea. Y equals square root of x plus 9 minus 2. This is a what shape? A ramp shape, and it goes how far to the left? 9, and then that's the last thing. Down 2. So in real world, I can go like this, ramp shape. And you know what you can do on your iPads? You could never do before because Notability does this, but the other programs didn't. You can do the little lasso thing around the parent function. You know what I'm talking about? There's that little thing you can loop and grab it. You can grab it, and then you can do like I can on my smartboard, and you can just grab the thing and move it. So if I want to go plus 9, that means up 9. No, wait, sorry, left 9. And then minus 2 means down 2. I can do that. I'm done. I've just moved it to the right place. So graphing it, grabbing it, moving it, that all could work. Now, if you don't want to make the parent function in the first place, if you don't want to make this parent one, you can do that, but then you have to do it by making an XY chart. Get your iPad open again and make an XY chart on a blank page. So insert blank page. Make an XY chart. Okay. If I want to make an XY chart for this graph right here, then what I want to do is put in numbers for X and Y that are going to work nicely for me. So in other words, since I get to pick anything I want for X, would I ever pick like 93? No, because it'd be a pain in the butt to graph it. So in this case, would 0 be a good place to start? Yeah, because if I put an X is 0, everybody put that on your chart, X is 0, then stick it into the equation and figure out what you should have. Don't say it. Figure it out. Write it on your iPad. You put in 0. What do you have? Then zoom in on that chart and show me. What do you have? What comma what? I'll tell you if you're right really quick. Yep. 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 Looks like pretty much everybody's doing it right. 1. Good. All right. Now I want you to find another point that works. I picked 0 out of the air. You could pick anything you want. I encourage you to consider picking numbers that'll have a nice square root when you're done. In other words, if you just put in 1, it's not going to be nice. If X is 1, you're going to have to do a square root of 10, which you don't know, and I don't know either. So I recommend you don't use 1. So figure out some other number combos that work. Give it a shot. I'll pause while you work on that. Okay, so you should have found me a few more points. I'll give you an example. If I put in, let's see, what's the next logical after 9? If I add 7, it's a good idea, because 9 and 7 makes 16. Then I can go square root of 16, which is 4. And then 4 minus 2 is 2. 7 comma 2, raise your hand if you had 7 comma 2. Did anybody get smart enough to use a negative number for X? Good idea. What did you do? -5. Okay, if I stick in a -5 right here, -5 plus 9 makes 4. Square root of 4 is 2. 2 minus 2 is 0. Did you have -5 comma 0? Then you did it right. Anybody else have any combos that work? Looks like we've exhausted all the common ones. Check. 16. So 16 and 9 makes 25. Cool. So you go 16 here. And then 16 and 9 makes 25. Square root of 25 is 5. 5 minus 2 is 3. So 16, 3 is a good one. The only bad thing about 16 comma 3 is it's not going to fit on most graphs. But it is a point. All right. Yes, sir. All right. What else you got? Oh, that's true. If you add 40 to 9, you get 49, and that's going to work. 40 goes there. And then 49 squared is 7, and then 7 minus 2 is 5. 40 comma 5. You could actually make an infinite number of points, because you just got to keep on finding bigger and bigger squares or smaller and smaller square roots that work. Okay, another one would be -8. You get what would happen if we put -8 in there? -8 plus 1 would be 9 would be 1. Square root of 1 is 1. 1 minus 2 would be -8 goes with -1. Okay, and when you graph those, you get your equation. All right, so you don't even have to like really understand the whole move shift thing to be able to do the XY chart. You can make an XY chart up for anything you want. Like you may have no clue what it even means. Like you probably have no idea what tangent looks like. But if you wanted to graph tangent of x, you'd have to use a calculator to figure out the tangent numbers. Okay? But if you want to do like, okay, I'll put in tangent of 1 and see what happens. You type in tangent of 1, and it would tell you what it is. And if you stick in a 1 here, tangent of 1, you use your calculator, it would tell you the answer. Let's say it's like 1.63. It's not, but then you could just find out an XY chart for any function. My point is on this, let's say that you're in the middle of this, and you have a test on it, and it's asking you to do this. And you're like blanking. You cannot figure out what that shape is. Okay, that would be one that could be on your test. XY chart can save the day. You can fall back on that for any problem, and you can know exactly what points are on that graph. You just pick numbers and try it. Pick a number for me for x. Okay, x is 2. I stick in a 2 right here. What's 2 minus 3? -1 squared. 1. 2 times 1 is? 2 plus 2 is? I know the point 2 comma 4 is on that graph. You know what I'm doing there? I'm just picking any number I want for x, and I figure out a thing that goes with it for y. All right, there are problems that are easier if you know, okay, I can tell you that that is a parabola because it's got the squared thing. I know it's a parabola. I know it generally looks like this. But I can do this pretty quickly if I want to just say, okay, it's been moved to the right 3. It's been down, or sorry, up 2. And then this 2 on the front of it is a stretch that makes it get wider. There's generally what my shape looks like, that blue thing. If I want the exact specifics, make points. All right, so that's what your homework is like for today. So let's go through a few more of the slides on there. Just match these up for a second. Find this slide and draw arrows. Like if you think this one goes with this one, draw arrows to them. I'll pause while you work on that. What happens when you subtract? It does go to the right, so it goes straight across. But don't think that they all just go straight across. That's what I thought at first. What happens when we add inside? It does not go up. When we add inside, inside is left-right. So if you're adding inside, that's left. What happens when we subtract outside? If anything on the outside is up-down stuff. Subtracting, when it comes to up-down, means down. And the last one is what happens when we add outside and it goes up. So that's what yours should have looked like. Any questions about that? Okay. So if you were going to do this one, the only thing I need to add to this now is domain and range. Would you agree that since it's squared that I'm going to have a parabola? And which way has the parabola been moved? To the right 4. There's 2 ways you could do this. 3 ways. You could graph the parent parabola over 2 up 4. Wait, that's only 1, 2, 3. That's simply up 3, sorry. Over 2 up 4. How do I know these numbers? Over 2 up 4. I'm going back to the parent parabola, and I'm doing it in my head. I'm going, I'm squaring every number. I take 0 and square it, I get 0. I take 1 and I square it, and I get 1. 2 and I square it, and I get 4. Anyway, you'll memorize these after a while. Okay, there's my parent parabola. And if you want, you can use your iPad functionality to clip this thing, grab a hold of it, and move it. So if I were to grab this, I don't want to, I can actually move the graph. That's a weird thought. A second, I'm going to lock that down. Locking, lock in place. Grab these guys. I'm going to move them. Where do I want to move them? 4 to the right. So I can grab them, move them 4 to the right. Come on. There we go. There. All my points have been moved 4 to the right. Option B. I can just start at that spot that's 4 to the right, because I'm smart enough to know what it looks like, and I know it's been moved 4 to the right, so I just start right there, and I make my little parent points there. Go over 1, up 1 in both directions, and then go over 2 and up 4 in both directions. See how I did that without clipping anything? All right, and the third way that'll always work, XY chart. I'd like you to find the XY chart for this. Give me 5 points that would be on your XY chart. On the test, that's what you'll be expected to do, is find 5 points. You can do them in any those three ways, but you have to be able to identify 5 points on the graph. Could you put in 0? Yes, you could. 0 would go with -4, sorry, 0 would go in here, and then I'd have -4 squared, which would be 16. 0, 16 wouldn't even fit on your graph, though. So that wasn't a great start. What would be smarter to start with? Maybe like 2, okay. Put in 2, 2 minus 4 is -2 squared, which is 4. 2, 4, raise your hand if 2, 4 is on your chart. Okay, good. Keep on going, get 5 points. And pause for a second while you do that. Okay. So, some other numbers. Let's try 3. 3 minus 4, -1, -1 squared is 1. 4. 4 squared, or sorry, 4 minus 4 is 0. 0 squared is 0. 4, 0. And then 5 goes with 1. Raise your hand if you had those. All right, good. Any others that you, well, you know what? I'm sure there's others, but I'm going to graph these now. 2, 4. 2, 4. It goes right there. 3, 1. 3, 1. 4, 0, 4, 0, 5, 1, 5, 1. And I would not say this is the fastest way, but it is a way that you can do it with the XY chart, and it's a way that always works. Okay, now that I'm done with this, should I draw a line through it? Yeah, you really should, but it kind of makes your graph more messy, so I'm okay with you not putting a line through them, because it's really hard to connect all the dots perfectly. But if you've got a real steady hand, and you want to draw your line through it like this, that's technically what you should do, because these are not discrete points. There's spots in between every one of them. In other words, you can put in 4.5 into this and it would work. You put 4.5 in here, so you can graph anything along this line. Okay, now what do I do with domain and range? I want to make sure you get domain and range. So once again, I'd like you to shut your iPads for a second and look up here. Just need your full attention for a second. Domain and goes this way. This way. If I extended this graph forever, how far would it go to the left? This is domain. -infinity. So its domain is -infinity until infinity on the right. And then range, I almost wish we wrote range like this. The lowest it goes is like, what is the lowest it goes? 0. To infinity is the highest it goes. Do you get why I kind of would like to write it that way? Because that's from the lowest to the highest. Okay. Besides, then I could make a face. Anyway, back to 0 to infinity really should be written this way, though. And here's an important point. You need brackets around the 0, because why? Because it can touch 0. How about infinity? Why don't I have a bracket? Can't touch it. They made a song like that. Okay. MC Hammer. Didn't work out too well for him in the end, though, because he went broke. Partially because he had a huge entourage of people. Like he had like 30 people like always around him and sucking money off of him. And he had so much money, he'd be like, here, car for you. And hey, let's all go to Italy or whatever. And all of a sudden his money was poof, all gone. Had like 22 million at one point or something. So, all right. This one, let's not even do it, but let's say where would have moved? What shape was it? A V. And where would it move? Which way, right, left? Which way is it, right or left? Right 5, and then what's that 2? Up 2. Domain and range, once I actually draw it, that'll be easy. So here's my V shape, and if I go right 5 and up 2, that's probably the fastest way for me to do it. And then I can say, what's this domain? Negative infinity to positive infinity. What's its range? From 2 to infinity. Do you get why people sometimes say the range starts with a 5? You're focused in on this point right here, and some kids go, oh, see, there's a 5 right underneath it. It's from how low does it go? And you really should be following on the axis here. It goes from 2 to how high would it go? Infinity. From 2 to infinity. All right. How about this one? What shape is it? I've used the R word, ramp. Different R words than one you're supposed to never say, but this is a different R word. So ramp. The ramp has been moved where? What? Okay. Do you not know the square root one is the ramp? All right. Okay. So the ramp has been moved which way? Down 4. I'll move it down 4. 1, 2, 3, 4. There it is. Now what's this domain and range? What's this domain? Remember, domain's this way. How far this way? How far that way? It's going to keep going that way. Why doesn't it go this way? Because you can't do negative numbers underneath the square root. If I put in like -2, it doesn't work. That's why it can't go that way. All right. And its range? How low is it? -4 to how high? Infinity. All right. Good enough. I don't think we need to keep doing more of those. The only thing, this one gets weird in that kids get annoyed when there's an F in the middle of their function. And they're like, get that F out of here. That's anyway. This F is telling you that it's a function. Right above it, it tells you what the function is. Do you get what I'm saying? That function is the square root function. So when they have the F in there, they're trying to say that the function you should be doing here is square root. See what I'm saying? So you could say, oh, so you mean this. Okay, if they had said above it that the function was really the x squared function, then you should really say, oh, so you want me to do that. Okay? So remember, if they put one in like that, you can get the F out of there. And put the square root in there. Okay? All right. And your homework looks like that. Go get them.